Thank you very much for your time and overwhelming support to this activity. I'm a GHJ, consultant to GHC, not GHG, greenhouse gas, okay? I've been working at this department for 16 years. So I joined this university from National University Singapore back into 16 years ago. After I was brought to see the beautiful campus, I love it, then I joined. Maybe I should say I'm not regretting, okay? Today I will talk about something new, hope that exciting you from something you can learn, something can be done in Hong Kong at HKUST regarding the new concepts of wastewater treatment and two applications. So not only writing paper as a professor, we also make contributions to the society in real sense. What means green? The words we always use green. Green to me means that saving space, reducing cost, reducing energy, while solving problems. You can use sustainable words, smart words, but I use here green. Green means, as an engineering guy, we need to get problems solved efficiently. Okay. Now, we have a lot of problems in our country, China, and particularly we have water environmental challenges in China. Number one, we don't have a lot of water. And we only have 30% of fresh water available to all Chinese, which only 30% of the world average, 2,000. And we don't have water. If no water means no life. No water means to Cantonese, no money. That's the reason we have a lot of business leaders here today. Water is so important. Everybody knows. We can buy energy something, but we cannot buy water. Only the way you can mention that you can argue, can we claim water from seawater? Yes, we do, like Singapore. But that is very expensive. Burning too much coals, we know. This is a textbook knowledge. But something that we need an innovative idea, we can solve the problem. Actually, Hong Kong, representing a very, very successful experience in solving water shortage problem. I don't know whether you know, we are the worst city in the world in terms of water resources availability. We only have 125, not 2,000, way below China's level. But we solved the problem. We are doing very good. We are even doing much better than Singapore. But you guys don't know. I'll show you later. Okay? We are excellent. We should have confidence. Hong Kong can do excellent work for the world. And at the same time, we have a lot of wastewater produced in our country, in mainland. You can read this number, 571 billion sewage wastewater produced per year. And only 50% are treated. You can think about what the problem is. It's a massive, huge scale problem. Water problem. Why we are lacking water? However, we are discharging too much untreated water. It's a vicious circle, worse to worse. Then the consequences of sludge treatment, wastewater treatment, resulting a byproducts, harmful, unnecessary byproducts. What is it? Sludge. The sludge is a tricky guy. Sludge cannot be easily dumped, recycled, reused freely. Sludge finally has to be burned everywhere. It will be soon in Hong Kong. It was burned in Shanghai, in Guangzhou, to some degrees. But it will be going to very large scale practice. We know the problem. Burning sludge is costly, it's energy intensive, and what's end on? Air pollution contamination. Okay? So Now, these are the big problems we are facing now, are the challenges. Then you wonder why this problem cannot be solved. Money is number one, sure, okay? But many times we have constraints of current technologies we have been using for 100 years. What problem we have? Number one, too much sludge produced, accounting for 50% of energy consumption of cost, space. In Hong Kong, we will produce 2,000 tons sludge in a few years later. What is the solution to this sludge? We know EPD will burn sludge. How much is it? According to my calculation, it's about 850 Hong Kong dollars to burn one dry sludge, 1 ton dry sludge. We have to pay it. But it's not sustainable for sure. All right? At the same time, the water treatment part is also too much energy consumed. Electricity used. 0.3 kilowatt for treatment of per cubic of wastewater everywhere in the world. It's too high. That's the reason why we don't have a lot of water treated in our country, because too much energy consumed. All right? And last one is also, again, too much space needed. So we need energy, money, and space all together are necessary to deal with this problem. That's the reason we cannot solve these challenges very efficiently. Here we're presenting you a HKUST innovation of new technology. I just remember the name, called SANI. I can tell you where the name from. SNI means half words of sanitation. Remember, in Chinese name is called killing sludge killer, sanai, sludge sasai, all right? But it's very powerful. Some people say it's very powerful naming, okay? I think you will remember forever this name, okay, after my talk, hopefully. Now, give you the background of the innovation. What is the sunny technology? What is the beauty of this sunny technology? Okay, look at the history of the development of 100 years biological treatment technology. Biological treatment is the main forms of, main technology of large-scale industry wastewater, domestic wastewater treatment. And the technology was invented by 2 British engineers in 1914, which we use a very simple way, natural way, that we pumping air, oxygen, pumping air to provide oxygen to oxidize organic pollutants, major pollutants discharged from us, and to convert organic matter into CO2, which we complete the natural cycle. Okay? It's a good idea. But the problem is that the oxygen is hardly dissolving guy. Lot of air pumping inside. In Cantonese, sai here. Only a few percent working. Most of them just sai. Just go through it without doing any contribution. That's the reason it's expensive. Secondly, that this conversion, no matter what you do, only can convert 40% carbon into CO2. The 60% carbon will stay in the form of sludge. So this conversion is not beautiful conversion. Energy intensive as half-baked. But it's a natural reaction we know. We can do it easily in Sati, in everywhere we do it this way. And so technology has been doing everywhere, and we know the problem. And now, by 1962, we have a few professors, they will invent another new thing that we can add on removal of nitrogen, because nitrogen is another major pollutant to our water bodies, causing algae blooming, algae growth, excessive algae growth. So we can aid in this reaction, again, using organic to do a denitrification to back nitrate from ammonia to nitrogen gas. Again, is nitrogen cycle, natural reaction. And this reaction cannot solve the problem because we still use oxygen. And this reaction, again, produces a lot of sludge, same as the organic oxidation, same. Okay? And now, we invented technology because we know that Hong Kong using seawater to flush our toilets for 50 years already, saving tremendous fresh water, 22%. Every day 750 cubic meter fresh water saved, much cheaper than Singapore's new water, I'm sure. They are only doing a few percent. We are doing 24%. Great engineering success. All right? Because this practice, we realized in 2002, can we do something to fit and to maximize the benefits of seawater toilet flushing and to get green technology developed. Now remember, the benefits of seawater toilet flushing is bringing a lot of sulfate into our sewage, causing problems, we know, smelling problems. This is bad side. We want to turn the bad side into good side. Now, the idea is that sulfate can convert organic carbon into CO2 very efficiently. That's the reason we have smelling problem everywhere in sewer, you know. This knowledge has been with us for many years. Of course, you tell me my mother is ready. Anything new? The new thing is here that we can convert this sulfate into CO2. Why this H2S won't be produced? No smelling. So the beauty is here. I'll show you later why. And that's a lot of people forgot. So when we search in the patterns, a little bit the pattern lot, but none of them hook up to the seawater toilet flushing resistant sewage, saline sewage, salty sewage. That then the product is that can utilize as a reaction for denitrification to convert nitrate to nitrogen gas. So we are completing carbon cycle and nitrogen cycle here without being bothered by oxygen. We don't need oxygen. The oxygen here is not from air. You don't need to pump a lot of air. You know what I mean? You solve the problem from the root. And this nitrogen cycle produces almost no sludge. That's good. I'll show you later the reaction equations, okay, something. And that's this nitrogen cycle. So this simple idea, by making use of sulfate originating from toilet flushing practice, and we can turn wastewater treatment into a green process, saving space, saving money, saving energy, and more importantly, we don't need to worry about the sludge anymore. That's a huge impact. Okay, so our news be released. I was told my friend, is 100 Chinese website news sites reported HKUST Sunny Technology. It's good PR for HKUST, sure. I think our president will be very happy, okay? And so this technology will redesign 100 years treatment technology because the concept changed. The concept will change from 2 cycle ideas used for 100 years into 3 cycles. Scientifically, it's new that we're adding this cycle. So everything changed from 2 dimension into 3 dimension. From car oxygen here into these 3 cycles. So we're linking this, all the reactions are natural reactions. We don't need to use any special bacteria. They are all natural bacteria, natural biomass. Okay, however, what we do is that we can introduce new reactions to realize something new in the practice of wastewater treatment. So this technology we named from the name of long name is sulfate reduction, is autotrophic denitrification, nitrification, integrated process shortened to SUNY. And since happened to be the Chinese name, killing sludge. So very lucky, okay? What we can do in terms application technology depends from the concept. The concept is okay. Then we can realize we can develop into a system, as a working system, which we can have 3 reactors. Number 1 is a sulfate-based organic conversion on the anaerobic condition, no oxygen. And USB, a sludge upper flow bed, which is quite common means of treatment. And then after that, we produce the sulfite, and the sulfite will be utilized in reduction of nitrate into nitrogen gas. And then we have this here. So the concept is sulfate from the beginning to sulfate again. And then you worry about any problem, no problem, because sulfate already be with us. We just turn around. We don't produce any harmful byproducts. At the same time, we don't have sludge. We are discharging our wastewater treated water into ocean. No problem, because natural cycle. We have a lot of sulfate in ocean. If you discharge it into freshwater body, then you should watch out the concentration of sulfate. So in toilet flushing areas, no problem. It is a natural cycle. You don't need to jump up, say, oh, any problem. No, no problem. Okay, this technology, after we try 3 years in lab scale, then we convinced the DSD to give us money. Let us try for DSD at Dongchong pumping station for 2 years over a very steady state operation, for 205 days. And with real wastewater, no sedimentation tank anymore. I just use 3 simple tower-type reactors, and the result giving us that, yes, the concept is correct, that we can remove almost 90% of the organic pollutants, a quite larger percent, 80% of nitrogen, while you can see that the effluent water is pretty clean, meeting the discharge standard. And the ESD was very happy, even though it's happy. And more importantly, we don't have any sludge discharged over 2 years. Every day we pump in 10 cubic meters. Then you can see material never disappear, for sure. Where is the fate of those non-biodegradable solids? To answer your question, that we can carry out balance analysis of the solids, and then we can divide into solids into biodegradable, non-biodegradable, everything covered up, and then to carry out the analysis, telling you that something may be out, 15%, most of them decompose again, and finally those sands, 80% sands, stay in the bottom of the reactor for sure. They never disappear. I'm not the magic guy. I'm not the magician. Okay? But telling you that every day this sludge produced only 0.63 kilo assets per day is only 2%, 3% of the normal technology. So we can take everything out sludge and to measure the quantity and to verify the calculation is a perfect match by the analysis. So clearly, we can show you that, convince you that this process technology produce a little sludge. Why? Then we can go further. As a scientist, we need a writing paper, convince a lot of scientists. Why? Because we can show you the reactions. The reaction is here compared with conventional organic matter. Conventional, we're treating 100 grams of organic matter, will produce 42 grams of sludge. Why this reaction produce only 1.9 sludge? Nothing. All right? And why produce an interesting thing that produces a lot of alkali, moving up pH very high. This is important. Well, I'm showing that because the pH high, it will make the H2S produced from the reaction dissolve in water 100%. You don't feel smelly. Otherwise, this technology is nothing new, no beauty. The beauty is that when we do this one, we have sufficient sulfate because we have seawater refreshing. Then we can raise this concentration alkali higher to keep at the pH high. And so then we can have 100% H2S dissolved in water and fully use it. And then you can see the reaction of autotrophic denitrification is also produce a little sludge. Compare with conventional one, that's talking about 24 something. So you can compare that all the reactions are slim guy, not the producer of sludge, where the sludge can be produced. No. So we don't need to put in any chemicals. We don't need to put in tricky, fancy bacteria. The natural reaction solve the problem for us. God help us solve the problem. Okay? What is the benefits of sunny perspective for Hong Kong? Only for Hong Kong. That we can reduce 2,000 tons sludge to 200 tons. We're confident that we can reduce 90%. At least our incinerator of sludge could be shrunk to very, very small one. And most of sludge from the sunny, actually we verify, can be utilized as construction material because the major component of the sludge of sunny are sands, inert glasses. Okay, no need to burn even, but I cannot too boasting because otherwise I may be not very, I would say not very much trusted. Okay, if I would rather say 90% sludge reduced. And we can reduce 36% CO2. Okay. CO2 compared with conventional one. When conventional sludge need to be burned, if we need to burn only 90%, we can reduce 36% CO2. You will argue with me that we can use anaerobic digestion of sludge to retrieve some of CH4 and recover certain energy as a biogas. But I'm telling you now, those energy is far below that required for burning sludge. Very little bit. So if we don't want to burn sludge, or burn sludge very little, then we can reduce a lot of CO2. And we can reduce, for business guys, we can save space and the cost by 50%. That's the reason why DSD is so interested. Okay? Now, DSD interest, we want to go further demonstration and for 1,000 tons in Satien, in an empty tank, because space there is a big problem. We don't want to disturb the operation of that big scale treatment plant. So we are allowed to use a small area to build 1,000 tons of demonstration plant of Sunny. Very tricky one, okay? And now we can have further reduction. We can make the Sunny more sexy. We can develop the sludge into a kind of granulars. I can show you later, I have a sample. And we can have 3 types of granulars. And we have very powerful granulars. And the granular means it is settling very quickly. We can combine the settling reaction in one reactor. We can save a lot of space. This technology has been already well developed in Holland. But we can develop the similar new types of granulars to reduce the space, I believe, 80% of the current version of Sunny. Make it much compact and make a user. Where is the application? You will wonder, you are talking about Hong Kong and you technology develop Hong Kong. Is technology develop Hong Kong only? My answer to you, no. we developed this technology as a platform technology for everywhere. Number one, this technology can apply in textile dyeing wastewater treatment. I don't know whether you run this business in our country. It's a headache problem, very expensive. The sludge is a huge problem, nightmare. So we can use this technology because in textile dyeing wastewater, the major pollutants actually is sulfate, high concentration sulfate. It's a perfect match to us, this organic and the sulfate. Because we use sulfuric acid to, in the manufacturing of, in the washing, the cleansing, we use it. So we use the sulfate also to adjust the pH, and you use a lot of alkali. So we are going to build our first demonstration plant in Nanhai, Guangdong. So because Guangdong government is loving this technology, interested. He said, no, nobody can solve textile dyeing problems. I stand up, we can do. Okay, so we are almost closing the final stage, getting money fund from Nanhai government. They have a lot of money, right? Maybe recording, I don't want to say anything, okay? Because otherwise I can't name anything, okay? Then the second one, how about the mining wastewater? Again, we use a sulfuric acid to process the ores. We have a lot of, mining wastewater is a big headache problem. No solutions. Now we step in, we can use mining wastewater to combine with freshwater sewage or even a sludge together. Okay, and then we can put together and adjust the ratio of organic and sulfate, so we can realize sanitary treatment again. Number three, we can even go more ambitious to solve air, water, sludge in one go, holistically, because power station is needed to do flue gas desulfurization. Very expensive. Once we use gypsum method, everyone uses gypsum method. We have a lot of facility already in a lot of power stations in our countries. I didn't say anything. But not every one facility are in operation constantly. Why? Very expensive. So we can propose to the industry that, come on, you just do simple absorption of SO2 into water. Let us handle for you. You don't need to go down to gypsum, because gypsum is saturated market. Used to be a product, but everywhere is do this one, getting cheaper. Okay, and then we can save a lot of money for power stations, and the waste can be due to two things. We can put in the sludge together with the FGD waste, and again we can solve the problem from the waste to resources. So here the waste become the resources to sludge treatment, and even we can put in freshwater sewage from sewer into FGD, and you can use it. Of course, you can wonder how we can do it. Yes, it's a political issue that because this technology system involving too many different department industries, not easy, I'm sure. But if for new cities, we can build the power station and treatment plant together. And even for sludge, we can, even for bit away, we can use a small pipe, because this waste contains extremely high sulfate, very high. You need a little bit portion of waste. Using small pipes connected to this current treatment plant, turn them into sunny, you can solve sludge problem and saving space energy. When I presented to Guangzhou government, they like the problem because power stations are not government owned, 100% controlled, because it's a business groups. Okay, you know what I mean? So you have convinced them. So, but we hope we can do another demo in Guangdong, maybe through our Nansha Huiyingdong Graduate School, and or through somewhere we can do it. So we are proposing this technology to to different governments. We can try. This is called holistic green environment technology for air, water, sludge together. Okay? Then we can save such cost, space, energy for wastewater treatment, for power station, industry. And then how about go much wild? Because in Guangdong we have a lot of river muds, dredging material come out. No solutions. Where is the mud goes after you take it out? No way to go. So then we can propose that we can have river muds, we can do simple grit removal treatment, get sands, gases out, and utilize as construction material. The supernatant, we can put in the chemicals to do high speed coagulation to remove the slurry and become then to be a part of sludge we can landfill. The supernet contains a lot of pollutants. We can using a power station FGD waste. We can build a ship, ferry, boat. We can build on the treatment plant, move in the boat, and close to the power station, get in the waste first, load it on, move to another river, and treat the river materials. Sexy idea, I'm sure. Not yet studied, because we are looking for donation of money and work together, okay? But at least Guangdong Science Technology Bureau, they are quite like it, interested, but taking money sometimes takes a lot of time. And we cannot wait for. We're already doing in our lab scale already. Sometimes you can come to my lab to see a lot of new idea technologies. Okay, then how about the technology talk to Japanese? Because Japan, they will not use seawater toilet flushing because they used to enjoy washing at the toilet. They use fresh water to wash their buttocks. You don't convince Japanese to come on, use seawater to wash their buttocks. Impossible. So what for Japanese do? Even for Taiwanese, for every city in the coastline, they refuse to seawater toilet flushing. Let's do this way. Fortunately, most of the treatment plants are building a coastline for easy discharge. That's okay. And we only can use about the water reuse effluent at most 30%, because we cannot reuse water everywhere unless you put on RO. Very expensive. Okay? So we only have 1/3 of effluent can be reused for irrigation, landscaping, water use, car washing, wherever, high street washing. And we can turn this idea. Let's do this way. We can remain the 30% as it is. Don't change. And the 2/3 pumping seawater from coastline into the treatment plant. The cost is nothing over 10 kilo. We calculate. Just only abstraction and sending the seawater into the treatment plant. Turn the treatment plant into sunny, and the sludge from here can be together. So we solve the sludge problem for the existing freshwater, wastewater treatment plants without being bothered by seawater toilet flushing. As long as it's located around the coastline, we can reduce 50% of energy. We can reduce sludgy part, eliminate sedimentation tank. You can think about how much space can be saved. And so now I stop talking about the Sunny and maybe go to another one. But it's linking back again to Sunny, that in the last 10 years, we also developed a new fantastic technology called membrane technology, which I know Ms. Eto is doing and many companies doing. In the last 15 years, 20 years, this is most advanced technology in the world, which means we put the membrane into the reactor to eliminate any clarified sedimentation tank, to reduce space, to solve sludgy bulking trouble. And that's really we invent a lot of membranes. But unfortunately, all the membrane in the world is clogged. You have to take it out, or you have put in chemicals, okay, to wash in 2 to 3 months. It may not be very costly, but looks somehow tricky, troublesome. Okay, but it will affect the lifespan of memory. And we develop some of technology we call low-cost membrane and no-fouling membrane, never fault. This is the first Chinese technology of MBR. We will present to, we already present, but we will disclose the patents because we apply American patent. So you will get what is it, sure. But this technology can be applied not only for airport, for everywhere, okay, and maybe in Saigon, I don't know. The beauty is that this technology have 100 times higher permeate flux. Very quick. It's not like 0.1, 0.4, 10 meter, which means 1 square meter can treat 10 cubic meters of wastewater, not 0.1, 0.4. So we can save a lot of material cost and lower air supply needed. Only 15. Air to water, only 15, not 30, not 40, not 50. And what we do, we only do backwash 1 minute using treated water, and once in every 2 days, not 30 minutes. This technology has been tried many times at HUST for 2 or 3 years, small scale already. And after that, DST be convinced, let's do for, this is the treated water, okay? And let's do for much bigger one, still not that bigger, okay? 20 cubic meters. And so now it's doing at Guizhong Industry wastewater pumping station. Everywhere pumping station, because pumping station have a lot of space, okay? And so we can do this one. This is our demonstration plants. Just start commissioning, okay? And DST wants to evaluate all the pros, cons, and the problems. Make sure this technology can be improved. Then we can go for larger scale trial, okay? This technology is so compact, which if it is to be applied in the future in Satien, and how much space we can save. We usually have this space now in Satien. And all these space boxes by red lines can be removed, no need. What we want to do, we only need this kind of space, indicated by this box here. We don't have sludge because we can put the sunny together. And this is perfect technology for moving our treatment plant into mountain cave. We can release a lot of lands for the society. We can turn the treatment plant into underground because it's a very compact. All the treatment plant is 6 hours. What is the conventional one? Even the conventional ABR, 10 hours, 15 hours, we only need 6 hours because our flux is so high. And hopefully, this process we give a special name called MOST. This is the ultimate version of our MBR. MOST not means Ministry of Science Technology. Okay, it's only this one. And here is the history of our technology, starting from trying everywhere, and I think it's mentioned in no time. Okay. Then the last one, we're taking a super technology. The super technology, it is that, maybe I go through this one, and seawater toilet flushing. And because of seawater toilet flushing, we can think of some new ideas, that whether we can recover phosphorus. Phosphorus will be diminishing in next 50 years. Phosphorus means the fifth element of life. No phosphorus, no life. It's simply as important as rare earth metals in the next 50 years. How much is the cost? The cost is, okay, now. So how we can do it? We can recover the phosphorus from urine, because urine contains a lot of phosphorus from urine. And usually what do, we can put in those kind of chemicals to human urine, then to produce a phosphate fertilizer called Wastewater. This is nothing new. But the new thing is that we can put in seawater. We don't need the chemicals. Why? Because seawater contains a lot of magnesiums, a lot of alkali God gave us. So we can do this one, and then we can do separation of urine from toilet. It has been widely applied in our country. Beijing airport, they are applied, but this is not water saving for different purpose. So waterless toilet, urine separate toilet, already is there technology. So we can get urine out of toilets, put in seawater, within 15 minutes, we can remove 95% P. How much is the P? The tons of P is talking right now in our China is 18,000 renminbi per ton. So we can turn our wastewater treatment real time, first time into profitable industry. Not only passive, business is here. Because in the last, every year, the price increase of P higher than gold. You don't buy gold, we buy the future, of phosphorus. Okay, remember, phosphorus will disappear, no way. And how much money can we bring to Hong Kong if we apply? We can produce at the moment 200 million Hong Kong dollar per year. Wastewater is the resources. It's not anything else. And go much wider. What is the future of Hong Kong? Smart water system for the future of coastal city that Hong Kong Airport doing excellent work. They develop 3 water system, fresh water, seawater, clear water. We can put together, turn around, can saving 50% of water resources. Much higher than 20% of seawater. And this technology can combine with a super technology. Finally, we can use sunny, so we can solve the problems a lot. And this means this technology, I give them, no longer call green. I call blue water technology because we use seawater. Okay, this blue HKUSD blue water technology can save the earth. We can save so much water, so much electricity, and recover so much P. And I take this opportunity to acknowledge my major collaborators in Holland, in South Africa, and all my teams. And finally, I give you summarize in what Lot told us. One water system, burning sludge, things like human beings want to conquer nature is bullshit. 3 water system, sunny technology, following nature. It is a highway to success. Thank you very much.
Wow, this is something very, very interesting. Never heard of it before. Before we go on to the question and answer session, Professor Chen, our president, would have a few words to say. Oh?
I should mention that the last system we were going to try in Nansha. Yeah, through Nansha. So, and I hope we have a lot of business leaders here. We can work together to establish a large-scale demonstration. It is for the future of Hong Kong and China. And technology involving pipeline, infrastructure, green building, wastewater treatment, resources recover is not only one point technology, it's a platform technology.
Well, thank you very much, Guang Hao, for giving a very inspirational talk. I knew very little about this. Okay, I came here. Yeah, I knew about the press release, and I knew about Sa Li. I thought it was a great name. But in a way, I think this is a typical example of, the Hong Kong can-do attitude is not known to the public. I mean, frankly, even to the person on the 6th floor in HKUST. So, when our school was founded 20 years ago, we were celebrating our 20th anniversary. This is the kind of thing that our founding members, had in mind, okay? Scientifically, technologically, it makes sense. This stuff should impress the peers. You can write papers, right?
Yeah.
You can get awards and so on. That's But more importantly, it produced a revolutionary technology. So, by the way, this is not just for Hong Kong, as he was saying.
For the whole world.
Okay, remember 100 years ago, 2 British scientists invented this, and everybody else used it. Why not? Why not Hong Kong invent a technology that the whole world uses? In the next 20 years, and you can make money out of it.
Sure.
Okay, I was going to say, okay, because this is not just not only saving the world, which is a pretty big goal already, but you can make. You see, I was just thinking there. You save space. I was thinking, a lot of people here would know how to use with those space, right? I was talking to Nick next to me. So saving space, saving money, saving the world, helping other people make money, producing papers, and inspiring our next generation.
Somehow like too good to be true.
Too good to be true, yeah. You have to tell us more of the challenges. But hopefully, also we're a research university. So Guang Hao you saw some pictures, a bunch of students and working with him, and those will become future leaders. We want them to have their ideas and so on. So in a way, in some sense, I always think of HKUST as the best kept secret in Hong Kong. You help fund it, all of us here help fund it. You probably hear about our rankings, our business school, there's a business school facilities. But we don't just do those. Those are very important to us. And you heard from Eden that when we go overseas, people hear about those. They open doors. It's like when you get in an interview, you need to say, I'm from this school, I know so-and-so. Opens the door. But at the end of the day, it has to be what you produce, what impact. So we want to hire more Guang Hao, okay? Okay. And I appreciate, this is a very, I know some of you, and I want to meet every one of you. I think by showing up, I know you're all busy people. By showing up, you supporting us. Many of you know Max. This is Max's idea. I hope maybe even if the reason you come is because you know Max. And when you leave, you hope you have obtained, get something intellectually. Also know a little bit about what Hong Kong Society HKUST is about. So thank you very much for coming. Yeah.
Thank you.
Actually, Professor Chan, most people here don't know me. Now we want to open up for questions. If anybody has any questions to ask from Professor Chan, or afterwards, you can have an engagement with him. Okay, please.
Hi, Max. This is interesting. I represent the government of Malta in Hong Kong. In Malta, they only thrive and they can only survive on recycled saline water. So does this apply to that? For that use as well?
Recycled saline water?
Yeah.
No, this is not applies to the saline water. At the saline water, we already use up to 20-some%. The solution, I think, is for maximize the further reduction of water demand. I would say like HKI, International Airport, are doing. We can, instead of recycling saline water, we should recycle grey water, which is cheaper.
What water?
Grey water. Grey water means a low, not heavily polluted water, generated from kitchens, from washing machines, not from toilets. Because toilet water we call black water. So we have yellow water, grey water, black water. And the white water is drinking water. We have 4 water. So you're talking about the saline black water is already such low level. Once you go up to high level, we can do, yes, but too expensive. I don't believe it's a smart idea.
Thank you.
Saline water means make water from salt, right?
Yeah,
seawater.
yeah.
Saline water is from seawater, yeah.
Any other questions?
Yes, please.
Professor Chen, this sounds like a disruptive technology because it's very different from what everybody uses.
Yes.
Now you said you are going to do a test. How soon, how long does it take for you to prove this technology is really workable?
The same technology will be, we plan to try from this year if money, DST can secure money very efficiently. We will start from, it already be delayed. It will be starting hopefully from this year, finish in 2 years. So that we can prove on production level. It's not trial level, so it's real level, large scale level. That's, I hope the government here will start apply, use. Otherwise, the technology will be used elsewhere. For HK university, okay, but for Hong Kong, maybe the rules. And for the non-falling memory, after our pilot trial, I think maybe a few years, we can do further large scale trial. And if any business leader want together can speed up the process, I think we can apply maybe in 1 or 2 years, because the technology has been with us for many years, not just 1 or 2 years. It has been 7 years. Yeah, all this technology I'm talking about to you has been 5 to 10 years, not new ideas anymore. New idea to you, not to me.
How scalable is it? Can you do it very small, or how big? And how about the temperature tolerance?
And we tried this sunny technology over the temperature tolerance 2 years, so which winter, summer, spring.
Is it for cold region?
Cold region, I would say the sunny technology for cold region, it could be a problem. But we use granulars. We can boost up the biomass concentration, can compensate the effect of temperature. Yeah.
Any other questions?
Can this sunny technology can apply to chemical water or nuclear sort of waste as well at the same time?
Nuclear wastewater is somehow, you need the absorption of the nuclear compounds. So this is a different story. But any chemicals, whatever the chemical industry, as long as contain a lot of sulfate, we can apply.
I see. So
We
you
can
can
combine
tackle
with different
chemicals.
technology. Yeah, yes. As long as cannery, if ever any wastewater contain high sulfur, report to me. We can work together.
I see.
Cannery,
Has it been
textile,
applied before?
nobody. We are starting to apply.
Or you are going to?
Yes, because it's new. Nobody thought of about this one before. Until you listen to me, you found out, yes, we can do it.
Oh, that's great.
Yeah, I was a guy in Vietnam. He learned the news. I want to work there. I say too far. Vietnam is too far, you know. Also, you don't have money.
Actually, one of the inspiration coming, to try to connect the university to the community was from a book called Crossing the Chasm. Where there was a book written in 1994 by a man called Geoffrey Moore. They were talking about how new technology is being applied into the real world, and it's usually through ideas that are connected to visionaries. And the visionary can think of in terms of a real practical solution, and then bring it out to the market. And then the next part would be for the early adapters to use it, and then we would have to have the pragmatists to use it, and finally the conservative would also come over. So this is one of the reasons why that we thought that there's so many exciting things that are going on inside the KUST, and the idea is how do we connect them to the visionaries and the entrepreneurs in our community. So if there's no more further question, it's not that you don't have it, but you just don't want to at the moment to come out with it. But give some thought about it, and if you do have some ideas or some more questions to ask before you want to commit or to get this message out to us, somebody who is applicable to it. For example, our energy companies in Hong Kong would definitely be very interested in something like this. Then by all means contact Eden's office, and then you get in touch with the professor. Thank you very much.
Thank you.